Okay, so we are moving on to section 1.6. And today we are talking about absolute value. Now when we talk about absolute value today, we're actually going to start with equations, which means if it's an equation, it's just an equal sign. And then, of course, we're going to do inequalities. All right, so here's what I want to talk about when it comes to absolute value. You need me to sharpen that? Sure, no problem. Look at here. All right, so when we're solving absolute value, first step is you have to isolate the absolute value. Step number 2, once you've isolated the absolute value, set up 2 equations equal to both positive and negative. Step 3, solve each equation. All right, so the reason we have to set up 2 is because there are 2 distances from 0, right? Either going to the right or going to the left. There's going to be 2 distances. So we have to set it up that way. So we're going to start off super easy. Example number 1. All right. Let's say we have the absolute value of 4x is equal to 20. First, is that absolute value by itself? Yes. It's all by itself on the one side. So now we're going to set it up into 2 separate equations. We have 4x equals 20, and we can say 4x equals negative 20. Now, I personally like to put my negative on this side, but it doesn't matter as long as you solve both of them where you pay attention to which one's where. Okay? So would you guys prefer I put the negative on this side and the positive on that side? Like we? Yeah. Yes? Okay. That's fine. It's whichever, you know what I mean? So I'm going to put my negative on this side and my positive on that side. So it kind of follows along with our number line. All right, so here I'm going to solve by dividing both sides by 4. So my first solution is x equals negative 5. Then dividing both sides by 4, my second solution is x equals positive 5. All right, and if I were to take both of those and plug them back in, negative 5, if I put it in here, I get negative 20. But the absolute value of negative 20 is positive 20. Same thing here. If I put 20, absolute value of 20 is still 20. Okay? All right, so let's make it a little bit tougher now that we remember how this goes. Example number 2. This is covering 10 through... Oh, we're starting at 12, sorry. 12 to, let's go with 18 so far. 12 to 18. Say we have the absolute value of 2x plus 4 is equal to, oh no, actually let me add, sorry, not equal to yet, my bad. Let's say 2x plus 4 minus 6 is equal to, let's go 10. All right, so we have to get the absolute value isolated. We have to get it by itself. To get this absolute value by itself, I got to move the minus 6, which means I'm going to add 6 to both sides. So I now have the absolute value of 2x plus 4 is equal to 16. Now that the absolute value is by itself on that side, we can split it into 2 equations. We have 2x plus 4 equals negative 16, and we have 2x plus 4 equals positive 16. So here I'm going to subtract 4 from both sides. I get 2x equals negative 20. Divide both sides by 2. And my first solution is that x equals negative 10. Very good. Over here I'm going to subtract 4 from both sides. I get 2x equals 12. Very good. And x equals 6. All right. So take it a little bit further. Okay. Still in the same section, just a little bit more. All right, let's go with example number 3. Example number 3. Let's say I have 2 times the absolute value of 3x plus 1 plus 6 is equal to 2. No, we can't distribute into the absolute value. What we need to do is get that absolute value by itself. Minus 6. Let's start there. Subtract 6, subtract 6. I have 2 times the absolute value of 3x plus 1 is equal to negative 4. Is that absolute value by itself yet? We have to divide by that coefficient. So we're going to divide both sides by 2. So now I have the absolute value of 3x plus 1 is equal to negative 2. Does everybody agree at this point? Okay. Now, at this point, we would typically split it into 2. However, it's already negative. So what does that tell you? Can an absolute value ever equal a negative? So this is no solution. So if you get to this point where your absolute value is by itself, but it's equal to a negative number, absolute value can never equal a negative number. That's why when we write our 2 equations, we take it out of the absolute value, right? Okay. All right. Okay, let's go with something a little bit different. Here's example number 4. Example number 4, this is going to cover your 20 through 24. Let's say I have the absolute value of 3x plus 5 is equal to 5x plus 2. All right, so first of all, is the absolute value isolated by itself? Okay, so we have to set up 2 equations. The first equation, we drop those absolute values, so we have 3x plus 5 equals the negative of this side, just like we did before. It's just it's got a little more math going on. Then we have 3x plus 5 equals the positive of that side. Good. So we have 3x plus 5 equals negative 5x plus 2, or sorry, minus 2. My bad. Minus 2. All right. Now I'm going to go ahead and move my negative 5x to the other side by doing what? Add it. So plus 5x to both sides. So I have 8x plus 5 equals negative 2. Now what? Subtract 5. 8x equals negative 7. Divide both sides by 8, and x equals negative 7 over 8. All right, let's go over here. We're going to subtract 5x to the other side. We have negative 2x plus 5 equals 2. Then we're going to subtract 5 from both sides. Negative 2x equals negative 3. Then we're going to divide both sides by negative 2. We get x equals 3 over 2. Now, in this section, because you have a variable also on the right, you have to do what we call check for extraneous solutions. Okay? What that means is by an extraneous solution is it's a solution that works, but when you plug it back in, it doesn't work. Okay? Yes, we got to plug it back in and see if it works. All right? So we're going to start by plugging in negative 7 over 8. I'm going to put it in here. So I'm going to start with, actually, I'm going to put in different colors so you can see it. I have 3 times negative 7 over 8. That didn't go a different color. There we go. Plus 5. Go ahead and throw that in the calculator. Tell me what you get. What did you get? Oh, yeah, I'm sorry. 2.375. I agree. Okay. 5 times negative 7 over 8 plus 2. It's a negative this time, isn't it? So are those equal? So we're going to go back down to our solution, and we're going to cross it out because it did not work. It is extraneous. Now we're going to do the same thing with our 3 halves. We're going to do it one more time. They have to work. Okay, so I have 3 times 3 halves plus 5. Okay, and then I have 5 times 3 halves plus 2. That one works. So this solution does work. Okay? Correct. Very good. You can just cross it off. If you cross off the answer, that tells me you checked it. Okay? Yeah. Those are the only ones for now. Like, later down in the year, we'll have to check it again. But, yeah. So just 20 through 24, that's what it's doing. Let's do a little bit more. Just a little bit. Because right now we're only at like 12 through 24. That's not very many problems. Let's just do a few more. Okay? All right. So now let's talk about if it's an absolute value inequality. All right. If you have the absolute value of x is less than or equal to a number, when we split this up, since that absolute value is by itself, we get x is greater than negative a and x is less than a. So you have one where you just drop the absolute value, and you have one where you flip the sign and make it negative. Okay? If I have the absolute value of x is greater than a, then when we split it up, we have x is less than negative a, and x is greater than a. So one of them you split it and make it negative. The other one you just leave it the same. This first one is an and problem. As you'll notice, the signs are pointed towards each other. It's sandwiched in the middle. You end up with an and problem. Down here, you'll notice the signs are going opposite. We end up with an or problem. Okay? This sign at the beginning will tell you if it's less than, it's going to be an and. If it's greater than, it's going to be an or. All right. So we're on example what? 5? Example 5. All right. So start off with, let's do 26 through 30. Then we might stop there. All right. So let's do an example through there. Let's say I have the absolute value of 3x minus 6 plus 3 is less than 15. So first I have to get that absolute value all by itself. How do I do that? Subtract the 3. All right, so I have the absolute value of 3x minus 6 is less than 12. Now I split it into 2. I have 3x minus 6, flip the sign, make it negative, and I have 3x minus 6 is less than 12. All right, on this one we're going to add 6 to both sides. So I get 3x is greater than negative 6. Divide both sides by 3. And x is greater than negative 2. Over here, I'm going to add 6 to both sides. It's 3x is less than 18. Divide both sides by 3, and x is less than 6. On our number line, let's see what we got. At -2, I have an open dot, and it goes this direction. At 6, I have an open dot, and it goes this direction. What kind of problem do I have here? And problem. Interval notation for the and problems, what, you guys? Perfect. All right. Last example. This is it. We'll do an or problem, and we'll be done. That's right. Example 6. Oh, goodness. All right, let's go with 2 parentheses 3x. Sorry, not parentheses. Absolute value minus 4 is greater than 16. Add 4, good. All right, so I have 2, absolute value of 3x is greater than 20. Good. Divide both sides by 2. Nice job. To 10, right? All right. So now what are our 2 inequalities we're setting up? Good. Good. We have 3x is greater than 10 over here. We have 3x is less than -10. Can you already tell what kind of problem this is going to be? It is an OR problem. Correct. All right, so here I'm going to divide by 3 on both sides. I get x is less than -10/3. Over here, I divide by 3 on both sides. We get x is greater than 10/3 on my number line, and -10/3. I have an open dot, and it goes to the left at +10/3. I have an open dot, and it goes to the right. Interval notation. -infinity to -10/3. Parenthesis, a u, parenthesis, 10/3 to infinity. Any questions? Okay, this is all review, so hopefully it's starting to come back to us, right? Okay, good deal. Yeah, let's just go to number 30 for you guys. We'll stop there. So 12 to 30.